morning. Let's get started here. Good morning. Is it better?
Much better.
So, thanks for coming again this morning. Hope everybody had a good night. And we're going to have a few more sessions this morning. And the one I'll be starting off with here, we're going to kind of continue on the open source topic. This morning we're going to actually show some stuff in action. Some Qgis working in conjunction with Arcgis Desktop, some extensions for Arcgis Desktop that sort of aid in communicating a little more easily with open source and open standards platforms like Geoserver and MapBox. Just a quick thing a couple things that came up last night that seemed kind of timely to me on Twitter. Two things. Tim O'Reilly referring to freeing the entrepreneurial bureaucrat, reminding us that public servants are eager to create better services. So I just thought that was interesting. What we're trying to, whether you're bureaucrats or not, I don't mean to offend, but the point is, that's what we're talking about, is getting things available to folks who serve the public so they could create better services. The other one was Brian Timoney. I mentioned him yesterday. He said, if you call yourself a consultant and never look outside the Esri stable of tools, then you are a salesman. I don't even need to expand on it. So today we're going to look at a few different things. Arcgis Desktop and Quantum Desktop, kind of sharing the same data set. Arc to Earth is an extension for Arc Desktop. We'll take a look at Geoserver and PostGIS databases, or PostGIS. We'll take a quick look at MapBox, possibly MapBox Studio, their desktop map authoring tool, although we'll kind of have to see where we are with time. CartoDB, we'll look at a few examples with some data that I prepared. I downloaded from the Madison police report, their crime data website, and then we also have some information, some data of the International Crane Foundation outside of Baraboo and some of their conservation and research efforts. And again, time permitting, we'll look at a couple of other things. MapFeeder is an application that our company had developed that uses WFS, Geoserver, open source, client-side libraries. That's all available on GitHub to look at. And also, again, if we have time, we'll take a look at Fulcrum app for mobile field data collection. So just a couple of quick questions. I'm curious, who here has tried QGIS? A lot of you. Okay, that's good. Who has done more than just run it? Who's used it for stuff? So half of you. Okay. Who knows about Qgis Graphical Modeler, which is very much akin to Model Builder in Arcmap? And PostGIS, who's downloaded that or played with that? A few of you. Okay. Geoserver, Andy. Why don't you just come up here? And then heard of. Who's heard of MapBox? Okay. Who's heard of CartoDB? Not including yesterday. Who heard of it before yesterday? And Fulcrum, who's heard of that? A few of you. Okay. All right, so this is where we jump out of the magic and jump into the stuff. All right, so we are in our happy, comfortable, fuzzy, warm Arcmap desktop here. Arcmap ArcGIS 4 desktop. Incidentally, Arcgis Pro, I don't know if anybody's been participating in the beta program with that. But with ArcGIS Pro, the personal geodatabase goes away. So if anybody is depending on the personal geodatabase, the access.mdv databases, Arc Pro will not consume those. So just an interesting fact. So we're going to go ahead here, and a lot of the things I'm going to show here are simple by nature. It's just to show some of the possibilities. So we've got a file geodatabase here from one of our customers, the city of Blaine in Minnesota. So we've got their stormwater utilities as a file geodatabase. We're going to crack that open and look at the things that we've got available to us, and we're going to go ahead and pull up the stormwater, or rather the surface water and the ponds polygons. So we're going to go ahead and just change our projection here. Just a note for people in Wisconsin, this matters. PostGIS, Geoserver can fully support all the county coordinate systems. It does take a little bit of tinkering to get those projection definitions loaded in because they are not standard, and nobody else on the face of the earth understands the plight of Wisconsin and Minnesota and maybe New Jersey, whoever else uses county coordinate systems. But they're fully supported. We'll go ahead and just add a base map. And while we're waiting for that to load, because I forgot to change the projection, we're going to jump over to Quantum GIS and essentially going to do the same thing. We're going to go ahead and view vector data sources. We have to pick directory for some kind of funny reason, I guess, because file geodatabase actually is just a directory full of flat files. When we look at that, we can go to source. Let's see what this is. Our type Esri file geodatabase. We're going to go browse for that. I'm going to jump over to Quantum GIS on my Mac because I know that opens file geodatabase. So we've got our geodatabase with all of our feature sets, feature data sets and feature classes. We're going to go ahead again and grab ponds. Go ahead and remove some of this other stuff I was working on. So there we've got our ponds pulled in from our file geodatabase. We'll go ahead and just do a quick symbology here. Style, category based on type. We're just going to pick whatever it tells us here for man-made basins, private and public water bodies, state. What we've got going on the background here in Quantum GIS is a Google map. There's another map available from a group called Stamen, which is their, what they call their toner layer. Things are going great this morning. So that's, again, just to illustrate the file geodatabases. What we're going to do now back in Quantum GIS is we're going to take some data sources. We're going to take a layer, push it up to PostGIS, publish it in Geoserver, and then we'll see how you can, back in Arcmap, pull things in directly from the PostGIS database and from the Geoserver web services. So we'll go ahead back to our Quantum GIS. Let's go ahead and grab another feature set from that Same geodatabase. Let's just do something simple here. Tmdl Boundaries. So these are the Tmdl watershed boundaries in this part, leading into the city of Blaine. So we'll go up to DB Manager, where we can manage all of our database connections. And we can see I've got a number of databases here set up, City of Blaine. We've got things here what are called schemas. Schemas are very much analogous to feature data sets. It's just a way to group information that is related to one another. So we've got a layer here called Utility Storm, and this contains a number of things, including feature classes. So if we look at some information about, for example, our outfalls, we see we've got our metadata here that's describing to us the projection, what the fields are. So very much an ARC catalog kind of tool. Are there any constraints on the database, domains defined? We can preview the data itself. And before we would bring it into Quantum or do anything with it, we can preview the features, also preview the features. Things work like 5 minutes before you get up here. Let's do what always works, is restart. So, there's a lake. We're going to go ahead and, in our City of Blaine database, we're going to take that feature and publish it up into this PostGIS database. So we've got our input is the Golden Lake layer. Our schema, where, in other words, what feature data set, where do we want to store this? We're going to just store it in our general map layers. And we're going to call it Golden Lake. So import was successful. Okay. If we now go into, again, we're still in our database here, we can open up this schema, and we now have got this feature set called Golden Lake, and we're going to go ahead and add that to our map. So as you'd expect, it just laid right over the top. The difference is this is coming from our feature data set. This is coming from our PostGIS database. And this database happens to be running out on our server on Rackspace right now. So I did take a little bit of a jump today and demo all this stuff live. So if we go back to Arc Desktop, let's see how this works. We're just gonna, I think we'll just do this with our catalog since time goes faster than I ever think it does. So we're gonna go into database connections. We're gonna add a database connection. No, I'm sorry. We're gonna first go into Geoserver. So again, Geoserver is similar in many ways to ArcGIS Server. allows you to publish your data as WFS layers, WMS map layers, WFS feature layers. It exposes WPS for web processing services, or just like Geoservices, so you can expose operations you build on out to the web if you want to expose tools that buffer parcels based on soil conditions. You can string that together with a server-side JavaScript function. You can use something called GeoKettle, which is, again, something similar to Model Builder, which will string together those operations. You publish then that as a processing service. So we're going to go into layers. We're going to add a new layer. We've got this set up for, we actually need to add a new data store. So data store, this is what's connecting Geoserver to the featured data sets in PostGIS. And so here it's showing us those features that are available in that feature data set in that schema. We can go ahead into ponds, which is something I had published yesterday. And this is where we would publish that layer and make it available. So if we jump over to layer preview, these are all the layers that we've published. I think I sent out ponds to the utility storm ponds. We're just going to do a preview on those. And so those are our features. This is a WMS layer, so this is just a raster layer where we can identify the features. If we jump back into Arcmap, we're going to go to our interoperability extension. So this is an extension you would have to load after you load ArcGIS, but it will, the unlicensed version of this will give you read-only access to WFS feature classes. So you can install this and connect to Geoserver for accessing the WFS features. So here I've got a couple layers already defined. I'm not going to go through the process of how you set up a WFS connection, but they are there. And there's our pond points. If I go ahead and drop that to our Arcmap session. So these are the point files. This is the point file that represents these ponds and when it comes to constructing the stormwater network itself for doing stormwater modeling. So in this case, I've connected through WFS, which exposes all of these as vector features, so you can symbolize these things. You can geoprocess on them just like you would any feature class. But they are read-only. You can also connect directly to a PostGIS database. I'm not going to go through that right now, but if you've got PostGIS running, you can set up a connection from Arcmap directly to PostGIS without needing ArcSDE or ArcGIS server. But again, right now anyway, it's read-only access. Which brings us to the extension here called Arc2Earth. So Arc2Earth is produced by some folks out west. And it's an extension that will let you connect to a variety of different types of data services. If we just go ahead and look at what we can connect to. So everything in green is the stuff that's working right now. So we can actually connect to ArcGIS Online for organizations. I'm not sure why you need to be able to do that here rather than just in ArcGIS itself. CartoDB, Map for connecting your Arc environment to your field data collection if you use Map. Geoserver, Dropbox, Google Drive, so if you're sharing information, a file geodatabase or shapefiles in Google Drive or Dropbox. And what this tool is going to do is keep that information, keep your local information synchronized with what you've published out on the web. So if you've got some data published up into Google Fusion tables or into a remote Geoserver Fulcrum field data collection, you can edit that local map session again as if it were any other vector layer. And any changes you make to that will get pushed up to those services and then visible to folks in the field, or if you've got, say, web applications that are built on top of Geoserver, they'll see that data, that new data changes immediately. So I would like to kind of jump over to CartoDB now. So we'll kind of leave the Arcmap world behind for a little bit. So CartoDB right now really is designed and really targeted for very quick, very nice looking data visualizations, including time series data visualizations. Their services are available on the web. They have a free account that you can sign up for, and then different pricing tiers that kind of have the usual service related to them, a certain amount of disk space, a certain number of map views, etc. They've also recently started their enterprise program, so you can have CartoDB, an instance of CartoDB installed locally on your enterprise if the cloud is sort of not really an option for you, or if it's something you want to run internally, you can do that. The enterprise level also, what we'll show here is sort of importing and exporting of some data files, a GeoJSON file, shape files, CSVs. But the enterprise level also will let you synchronize directly with other services. So if you've got a local PostGIS database, you can have that synchronized to your CartoDB instance to have that data updated automatically. So just a quick map of, well, let's just get into some of the capable example here. So this is the time series map, just on the news 2 days ago. So this is showing tweets related to the Ebola situation. So every time somebody sends a tweet out and they mention the word Ebola or things related to that, a little dot flashes on the map. And as we get closer to the end here, we'll see what happens in the U.S. in particular as that fella arrived in Dallas who was infected with the virus. It just kind of illustrates, something just happened. Ah. And I like how they use the orange fire to indicate bad. This is bad. So we'll jump in to Carto and just kind of show over the next 15 minutes how easy it is to just do something like that yourself. So we're going to go ahead and log in. Any maps that you publish in CartoDB can be public or private. There's also an entire API available, so if you are developing a leaflet map, example, or an open layers map. You can use the CartoDB JavaScript API to work with your data, to send queries out to your data, even apply updates and additions to change the data behind the scenes. And you can make these applications private, you can make them available to the public. I think the free account, when you first sign up for CartoDB, the free account assumes that everything you're doing is public. Again, that's fairly typical of services that kind of give that bottom level away. So we'll jump into our dashboard here. And I've got a number of data tables that I've uploaded. ICF Briggsville, this is the International Crane Foundation just outside of Baraboo. Some sample data that they're allowing me to use. Some solar data. So this is information from the state of Minnesota where we recently generated our statewide solar suitability layer. So for every 1 kilometer on the ground, this data set will show you what is the potential for solar power in that square of ground across the entire state. And so what I've taken earlier was the Madison Crime Map. I think, Andy, did you send me that, I think, or Jim did?
Yeah.
I downloaded a bunch of crime data from this website in Madison. 37,000 records, I think. So we're going to go ahead and just upload that. So that's done. So we'll just take a quick map view of this data. You've got a number of base map options built right in. They have an agreement with Nokia, here.now, to use their base maps. You can also bring in your own custom base maps. So we happen to work with MapBox, where we do all of our custom base maps for our clients. So we can set up that provider as the base map provider. And you can also set up sort of general XYZ tile layers. If that doesn't mean anything to you, don't worry about it. But basically it means you could take something like Arcgis server map layers, just the base map layers, and you could bring those in as well. WMS layers if you're sort of a that prefers open standards. NASA, I'm not sure what that is. So this is just our raw data. We're going to go ahead and look at the wizard here for visualization. We're just going to go and the standard things you'd expect to be able to do. Even more maybe cluster markers. So as you get further in, those break out to smaller and smaller areas. Categories, where we can go down here and tell it what the categories are. You've got control over your marker size. And again, right now we're just working with point data, but it's all polygons, line, any GIS vector data. And what's behind the scenes here is post-GIS. So this is not just for visualizing your data, you can also do analysis. So just about anything you can do with ArcGIS Desktop insofar as vector analysis, your topology operations, your buffers, your intersects, your nearest points, all of that you can do directly in CartoDB. Intensity maps. Again, fire, bed. And then this thing called torque, and torque cat. What we're going to do is we'll turn on torque. You can see it's starting to do kind of what we were looking at. We'll change to a little darker base map here. What that Ebola map was showing was time series animation. What I'm going to do here is jump over to a visualization that I had created and saved for the International Crane Foundation data. So what I'm showing here is a query that, just kind of keeping, without getting into too much detail, I'm looking at, so this is a series of crane observations in their Briggsville research area over a period of about 10 years, early 90s. Actually, I guess that's 20 years. And I'm selecting out really just the top 7 birds that they have observations for. So in other words, they are monitoring dozens of birds that have U.S. Fish and Wildlife tags on them, but we're just looking at the top 7 of those. In other words, the ones that they have the most observations for. So we'll go ahead and add that. That expands our data. We can go back into our wizard, and we'll do a little category just to show the radio number here. So this is the radio frequency number that those birds are being monitored with. And you can see, if maybe we have my other base maps available here. Oops, base map. You can see by these colors, it's pretty obvious these birds have territories, right? So these are all the observations over a 10-year period for bird at frequency 148.062. He is a good-looking fella. Now, if we jump over to our torque categories, we're in fact going to quickly just switch to the top #1 most active bird. We're going to visualize the time series of this guy, his movements. So I've got a time column here of radio timestamp. Marker type is ellipse. I'm going to leave cumulative off for now. We're going to make this, we're going to slow this down a little bit. So duration, 120 seconds. Change a couple of other factors here that, again, I'm not going to get into. Number of steps, which sort of controls the smoothness of the points, how they're appearing. So this is 1999. We can go back and turn on cumulative. And what that's going to show us is, instead of just showing us the blip for each of those points, it's going to leave them on the map, and they'll accumulate as each one shows up. So the last thing I wanted to just show here also, and the extension has a data link provider for CartoDB as well. So with the Arcgis extension, with the Arc to Earth extension, you can work with your data in CartoDB and edit it live in Arcmap. So we're going to bring up the